I hope you're all doing well. I am Mr. Ish. Thank you for joining me. In this video, we're going back quite a bit in terms of looking here at algebra, but age problems and expressions related to age problems. We'll look at just a few questions. You know, these type of questions show up on standardized exams. Our first one being this: if J is an individual, he was 32 years old 8 years ago. How old was he X years ago and 18 years ago? It seemingly could be a tricky question, but it wouldn't be if you just look at it exactly what you have right here, which I'm underlining. Just look at this underlined portion. If he was 32 years old 8 years ago, what does that imply in terms of how old he is now? All you have to do, if he is 32 years old 8 years ago, then he's 32 plus 8 now, which means right now he's 40 years old. You have obtained this 40, and this is exactly what you need, this 40 to answer this. Let's look at A. How old was he X years ago? Well, all you have to do, your answer would be 40 minus X, and whatever that would be, anyhow, it's just an expression, and that's all we're looking at right here. And this right here would be the answer of A. You have to solve this to determine 40, then from here you do question A. Question B, you know question B is easy. It'll be 40 minus 18, and whatever that would be, and that would be your answer. And that right here would be 22. X years ago he was 40 minus X years old. 18 years ago he was 22 years old. And this question has been completed. Let's just change this question a bit. It's exactly the same thing. If J was 32 years old 8 years ago, how old will he be in X years and in 10 years? Well, you know, you already determined his current age to be 40. In X years, you know what that would translate to. He'll be 40 plus X. That's not too hard, 40 plus X. And you know here it'll be 40 plus 10. And this right here would be 50 years. In X years, he'll be 40 plus X years. And in 10 years, he'll be 50 years. Because when you're looking here into the future, you're always doing your addition. When you're looking here into the past, like we were in the previous part of the same question, we were doing the subtraction operation. So you have to remember that going ahead into time you add, going back into time you subtract. So now let's just twist things around just a little bit. Let's look at this question. If J is 2 less than twice his sister's age, and sister is Jill, 10 years ago Jill was 15 years old, what are their current ages? How would you go about doing this? We're looking here at a brother and a sister. J is 2 less than twice his sister's age, Jill, but 10 years ago she was 15 years old. Determine the current ages. You can do this by means of a table of values, and let's do this. We'll put over here the algebraic expression, and then we'll start adding things to our table. We know nothing about Jill in terms of algebra, other than we have a relationship between J and Jill. If Jill is X, J is 2 less than twice his sister's age, 2X minus 2. 2 less than twice his sister's age, and that makes sense. Now let's talk about what's going on here in terms of the past. Jill was 15 years old, but we're looking here at 10 years ago. 10 years ago means a minus 10. And then we'll put an equal column over here. We know 10 years ago Jill was 15. So we're kind of getting a good expression here for Jill. X minus 10 equals 15. But we're also getting an expression for J. You can add these up. 2x minus 2 minus 10 is a 2x minus 12. Now, what are their current ages? Well, let's see how we can do this. Let's see what Jill's age is. X minus 10 equals 15. X is equal to 25. From this 25, you can put it right over here, and you can get an idea of his current age. It would be 2 times 25 minus 2, which would be 50 minus 2 is 48. So that's what we're getting here, 48 and 25. You didn't really need to even utilize this unless the question is or was, what were their ages 10 years ago? In that instance, then you can solve this. 10 years ago, all you'd have to do is just plug the value x here, 25, into right here, and you would go for 25 times 2 minus 12, and you know what that would be. 50 minus 12 would be 38. The current ages are 25 and 48. The historical ages 10 years ago are 15 and 38, and the answers would be right. That's exactly how you would do this type of question. Let's look at one more question for this video, and that'll be it. J is 10 more than Jill's age. 10 more than Jill's age. In 5 years, J will be twice Jill's age. We have to determine the algebraic expressions which can demonstrate everything we have over here. It's not too hard. Just start with J and Jill and exactly what you have in terms of a column. The algebraic part right here in the first column, we know J is 10 more than Jill's age. We don't know anything about Jill's age, so we make it as X. But we know J is 10 more than Jill's age, so that's just X plus 10. Now let's talk about this. In 5 years, you know you're looking here in the future, but that means a 5 plus a 5. And then we do an equal column here, which kind of gives an idea of what we are looking here in terms of expressions. We have x plus 5, and then we have x plus 10 plus 5, which is x plus 15. Now these two items will help you get to your final expressions, which is the algebraic expression we have to determine. In 5 years, J will be twice Jill's age. This person will be twice this age. It will be x plus 15 will be is synonymous with equal, will be twice Jill's age. And that's exactly how you would do it. X plus 15 is equal to 2x plus 10. And then you know you can do x is equal to 5. If the question was now what are their ages, you can do right here, plug the x here in terms of this, you're getting a 5, you put this over here, you're getting a 15, and it makes sense. 15 is 10 more than Jill's age, 15 is 10 more than 5, but in 5 years this becomes 20, this becomes 10, and they have a relationship of 20 being double the 10, and that makes sense, and that confirms that everything here is good. So remember, you can always do here in terms of a column what you know in terms of algebra, then what you have in terms of past and future, and then what you have in terms of the equal of those, and then you do the expression of one with regards to the other. Here we know J is twice Jill's age, so we did J is equal to twice Jill's age, and from there you go into your determination for X, you plug it into your original to determine their current ages. You can also plug it into your last column to determine either their future or their past ages, and that's about how you would do these age problem expression questions. And that's all I want to present for you in this video. Thank you for watching. Have a good day.